Let's talk about the real numbers. This is something you've seen before in Algebra 1. The real numbers are our way of classifying the numbers we use. Lots of numbers, fractions, decimals, square roots, etc. This is a picture of the real number system, and we can even draw a box around this and say that all of these numbers, all of them are real numbers. The two big divisions in the real numbers are the rationals and the irrationals. And remember, we talked about these a lot in your Algebra 1 classes, saying, what's the difference between rationals and irrationals? It has to do with fractions and how we can write them. Basically, you will never see a fraction in the irrationals. If something can be written as a fraction, it goes within this rational category. So, rationals, we can say down here, can be written as a fraction. The other thing about irrationals is these decimals that go on and on and on and on and on forever, right? 2.718281828, etc., it never ends, and it never shows a repeating pattern. You might see a pattern in the irrationals like this: 3.10100100001. You say, oh, Miss Hanson, there's a pattern to the zeros. There is, but it's not a repeating pattern. Only repeating patterns can go in the rationals. Irrationals are never-ending decimals with a non-repeating pattern. That's what we mean for irrationals. Never-ending decimals with a non-repeating pattern. If you go ahead and you look at pi, that is 3.14158, etc., etc., etc. If you try to find the square root of 2 using a calculator, you get 1.414213 something. There's no pattern to it. So that's why these are in the irrationals. So rationals can be written as a fraction. That's true. They can also have decimals. But notice these decimals here. This one, 11.23, it stops. Or we say it terminates. There's no dot, dot, dot. So a terminating decimal can be in here. Or 7.12 with this bar. That bar means this. It means 7.12121212 dot, dot, dot. That bar means that you keep repeating the pattern. So rationals can be terminating decimals, meaning they end, or they have a repeating, that's important, a repeating pattern. Now, there are tons and tons and tons of irrational numbers, lots of them. But we only have one circle that we're going to worry about. Just all those numbers go in there. Rationals, there's still a lot of them, and we're going to break them down into more groups. We're going to break them down into integers and into whole numbers. Integers are what you normally think of when you think of a number line. You think of the number line going from, say, negative to 10 to positive 10, but remember, it goes off into all different levels, so you could have negative 200 in here as well. You cannot have decimals in here, so this one cannot come in. You cannot have fractions in here. So this has positive and negative numbers like you would see on a number line. You could also have 0, which is why he's inside the integers here. So think of integers as being like the number line. Positives and negatives. Notice that we also have positive and negatives even outside the integers. You can have a negative 9 halves. We could have made this a negative 7.12 repeating. So positives and negatives can still be out here as well. Positives and negatives inside the integers. In the whole numbers, it's only positives. Okay, only positive numbers. So starting with 0 and going up through infinity. And again, no decimals or fractions in the whole numbers. because they can't come into the integers. So the whole numbers are an even smaller set. So down here, only positive integers. Now, you might see some statements that ask you which sets of numbers, and by sets we mean these little circles, what sets of numbers are within other sets of numbers. So let's take a look at these statements down below, but I want you to keep this picture in your mind as we do so. So, rational numbers are what real numbers? And the words we want to use here are going to be always, never, sometimes. So rational numbers, are they always within that real numbers category? Well, we said the real numbers was that big box, so yes, rational numbers are always real numbers. Rational numbers are something integers. Well, can a rational number be an integer? Yeah. Remember, the integers are within the rational numbers here. So some rational numbers are in here, but there's a lot of rational numbers out here that don't fit into the integer category, like 7.12 repeating is not an integer. So we'll say sometimes integers. Rational numbers are, irrational numbers are always, well, the only thing irrational numbers are is that they're irrational and real numbers. So irrational numbers are always real numbers. Irrational numbers are never, and they can never be rational numbers. Those two boxes never overlap. Okay? Notice here, you can never be in rational and irrational.